Hello. In this video, we will discuss about how to vary temperature in Ngspice. In previous lecture, we discussed about how to use for each loop. In this lecture also, we'll do bit similar thing to vary temperature also. In previous lecture, we varied model parameters and parameters of the MOSFET. Here I will plot ID versus VGS, same as previous lecture, but in this lecture, I will plot by varying temperature. Yeah, all right. Here I have written few lines of netlist. Here I have defined voltage sources and included the level 1 model file, which looks like this. Yeah, and defined the MOSFET M1 as shown. And here level 1 NMOS is named as red sub N1. So I have used here the same name and given some width and length and did a DC sweep for voltage source VGG. Fine. Now let us write control block how to perform these ID versus VGS at different temperatures. So I'll write control block dot control in the similar manner how we did in previous video. We have to use for each loop. So for each variable name I'll take as variable and I'll take temperature as 0 degrees, 25, 50, 75 and 100. Yeah, and now we have to vary temperature, right? So we will set temperature. This is the syntax to vary temperature. So what we are telling in this spice is set the temperature according to the variable values. All right, Ngspice will perform our required analysis at different temperatures. Now we will run this loop and end, and we will plot the things. What we required is ID versus VGS, right? So there we performed DC sweep for VGG. So we will plot for the first iteration as DC1 dot VDD hash branch current flowing through branch VDD with the flipped sign. We know how why we are using my flipped sign here. We have discussed in the previous lecture. Similarly, I'll do for all remaining 2 to 5. Yeah, now, yeah, all right. Now I will end this control block and end the snippet. So what we have did is first we defined the voltage sources, then included the model file, then defined the parameters of MOSFET, and then I have performed a DC sweep. Then in control block, what I did is for varying temperature, I have used for each loop, in which I am setting the temperature whatever the values are there for variable, and then I am plotting the each iteration values like DC1, DC2, like that. Yeah, now I'll save and I'll run what will be there. I'll see. Yeah, we can see here how ID is varying with respect to VGS at a different temperature. We have seen here for the first iteration, it's shown in the red color, which is 25 degree. So I'll zoom and I'll see what is happening. Here we can see that around certain voltage, the curves are behaving differently. It is increasing with increase in the temperature, and later on it is decreasing. Like it is behaving differently at certain voltage range. This voltage range. We will see why this is happening. Like brief discussion. Yeah, what is the reason is below threshold voltage, we know that there will be weak inversion. Due to weak inversion, there will be minimum number of charge carriers in the channel. So if we increase temperature, there a new electron hole pair gets generated. So due to that, current will increase. So what is happening below threshold voltage is due to weak inversion. If temperature is increased, charge carriers will increase. So it will give rise to increase in current. And after threshold voltage, what is happening is we will be in full inverted stage. So there will be no furthermore electron hole pair generation. So if we increase temperature, the mobility of the charge carriers will decrease. So due to decrease in the mobility of the charge carriers, the current will reduce. So that is the reason why below threshold voltage, as the temperature increases, current increases. But whereas after threshold voltage, if temperature is raised, current will decrease. Yeah, that's it for this lecture. In next upcoming lecture, we will discuss body effect of the NMOS transistor and how it is happening. What are the causes? All right, thank you.